All right, Algebra 1, here are your 1-4F notes. Basically, what we're going to be doing today is starting our exponent rules. But let's start with the bell ringer and go through the type of problems that we looked at on the previous day's notes. So first of all, first thing that we're going to do is we're going to take our variables and we're going to plug them in here for A and B. So I used red for A and green for B. So when we plug them in, A is 2 and B is 3. So we plug those in there, and then what I did was, since I recognize I have a negative exponent, I made it a fraction over 1 and moved the problem down. So the first thing, I took this 2 to the negative third, and because that is a negative exponent, we can't have that, so I move it to the denominator. So if we look here, the 16 and the 3 squared, they both had positive powers, so they stayed right where they are. But the 2 had a negative power, so I moved that down. And then I went through and I did 3 squared is 9, 2 to the third power is 8. And you can do this one of two ways from here. You can either say, well, I know 8 goes into 16 twice and have 2 times 9 to give you 18, like we have down here for our final answer. Or you can multiply 16 times 9 gives you 144 and then divide by 8. Either way, you're still going to end up at 18. So you could do that differently, like 16 divided by 8 is 2. Alright, so before we start with any exponent rules, let's just review what these parts are. Now, we have a 3 and a 4 here. The 4 is your exponent, and the 3 is what's called the base. So when we are multiplying powers that have the same base, we do not change the base at all. The only thing we do is we add the powers. So you can see down here, we didn't change the x. All we did was add a plus b. All right, so let's go through some examples of this and I'll show you. So what I'm saying here is we're going to take this 11 to the fourth and 11 to the third. When we multiply those, we do not multiply the 11s. All we're doing is we're going to take and add the exponents. So we're going to bring down the 11. Oh, there it is. We're going to bring down the 11 and then add these. So 4 plus 3. Okay, we don't multiply 11 times 11 and say 121. The 11 stays the way it is. We add those exponents to get 11 to the 7th power. Now, typically when we have something like this, you can plug that in your calculator. You can see that this one's going to be a pretty big number, so you could have that number though. Like this is the same thing as 1948711. It's a pretty big number, but you could also just leave that as 11 to the 7th power. So next, same idea here. If we're doing multiplying with the same base, we're going to keep that 5 the way it is and add those exponents. So negative 2 plus 2 gives you 0, and if you remember from the previous day's notes, or a couple days ago, anytime we have something to the 0 power, that's equal to 1. If we started out by doing our negative exponent rule, then we would say, well, I have a negative exponent, so I move that down. So I would take this 5 squared to the negative second, move that down. 5 squared is 25, 5 squared is 25, 25 over 25 is 1. Same answer, different way of doing that problem. All right, let's go through this one together. So again, I'm not multiplying 2 times 2. I recopy the base and I add the powers, 4 plus negative 3. Remember, 4 plus a negative 3 is the same thing as 4 minus 3, so that's just to the first power. 2 to the first power is just 2. Next, here you can see I already have this one done out. I didn't have it covered up because we'll just talk through it. It doesn't matter how many copies you have. If they all have the same base, we bring one copy of that base down, so I have 1, 7, and then we add the exponents, negative 3 plus 2 plus 6. Okay, you can add them all together at the same time. Negative 3 plus 2 is negative 1. Negative 1 plus 6 is 5, so we have 7 to the 5th power, or 16,807. They're both the same. And if all we're doing is showing the exponent rule, this would be sufficient. You wouldn't have to do any more than that. All right, let's do this one together here now, because now we're throwing in variables and exponents. And coefficients, the numbers out front. So what we're going to do first is anytime we have something like this, even though the 2's have the same base, Remember, this is still a multiplication problem. So let's multiply those numbers first. 2 times 2 gives me a 4. And then I'm going to say n and add those powers, 5 plus negative 2. So the 4 will stay the way it is. N, 5 plus a negative 2 gives you 3, and that is your final answer. Remember, this 3 does not go with the 4, it's only with the n. The only way it would be with the 4 is if we had something like this. But we don't have that, so we don't want to think that it's 4 to the third power and say that's 64. So that the exponents only go right to the variable or the number right to the left, immediately to the left, I should say. All right, here's another one. Again, I have this one done for you, so just follow along with me. Feel free to pause and rewind at any point. So first up, again, we are multiplying. So we'll multiply these numbers, 5 times 2 times 3. And then, so 5 times 2 times 3, which is 30. And then we're going to take our exponents, or I'm sorry, the variables, and add the exponents. Well, the y only has one term. There's only one y to the fourth, so that's not going to change at all. But for the x's, we're going to add those, and we end up with 1 plus a negative 8, which gives you a negative 7 that you can see down here. And then y to the fourth. But I didn't finish this one out, and I did that on purpose because we have a negative exponent. So from previous notes, we know whenever we have a negative exponent, we put it over 1. We identify and circle the problem. So just the x to the 7th, the 30 does not go with it. Okay? That 30 is staying up top all by itself. Or well, not by itself, it has the y to the fourth, but that 30 does not come down with that 7. So the 30 and the y to the fourth stay up there. The x to the 7th goes to the denominator and becomes positive. So that is your final answer for that problem. All right, so let's move on to the next one here. And again, I have this one done for you. So again, we're working with the same bases. So you can see here that we have two a terms. I have this a term and I have this a term. So we're going to add those powers together. And then I have the b term here and a b term here. So we'll add those powers together. So we have two separate parts to this. So here's the first part, a, add them together, 6 plus 2. Okay, 6 plus 2 is 8. And then b, negative 3 plus a negative 2. Well, negative 3 plus a negative 2 is going to give you 5, negative 5. Just like the last problem, I recognize that I have a negative exponent. That's not okay, so I circle the problem. I move it to the bottom. A to the 8th stays up top. B to the 5th moves to the denominator. There is your final answer. Last one. This expression, 5 to the 2nd times 5 to the n, is equivalent to 5 to the 11th. What is the value of n? So what we want to do here is just set up a little equation. 5, if these two are being multiplied, that means we have one copy of 5, and then what do we do with the powers? Well, we just went over it. We add them, 2 plus n. This has to be equal to 5 to the 11th. Now, if these two are supposed to be equal, then that means they already have the same base. That means 2 plus n has to equal 11. So you could just think in your head, what do I have to add to 2 to get to 11? Or you can just set up an equation. 2 plus n has to equal 11. How do we solve this? Well, we get rid of that 2. It's a positive 2, so subtract 2. 2 minus 2 is 0, and then we have n equals 9. So there is your final answer for the last one. Again, if you have any questions, just rewind, watch the problem again. If you're still not sure about something, you can ask in class or send me an email, private comment, anything like that, and just let me know what the problem is, and I will do my best to try and help you out.